Welcome everyone to the 28th episode in our space shooter DevVenture. So, in the last session, we concluded the code review of our DeepSeek code generation. Okay, so now what I want to do is I'm going to take this and I'm going to copy it and I'll paste it into a new script. So if I go in my file system under scripts, let's find scripts. Oh, it's already here. So that's under behaviors. And what I want is enemy AI, enemy ship behavior. Let's make a new script here called npc behavior manager.gd. And it inherits from node, which is correct. It only needs to be from the white node and not the red node and not the blue node and not the green node, just ordinary plain generic node. Okay, so create that and then open it. What is going on here? Why is this so? It needs to be like halfway. Okay, so now we've copied the code. Let's paste it. Cannot find member pattern assigned in base enemy ship controller. Yeah. Is that the only error we have? Not bad. Not bad at all. Okay, that's cool. Now all we have to do is open up the enemy ship controller and create these signals. Where are they? Pattern assigned and pattern cancelled. So here we go. On the top, we just have to say here by signals. We create two new signals with documentation, of course, later. For now, we don't need to worry about that. We'll just say a new signal and we'll say pattern, nope, small p, pattern assigned. And what does it take in? Emit pattern failed with these. And pattern assigned okay, so that's what it looks like. I want to make these aligned. Remember, I like keeping things aligned in their columns. Yeah, that's better. Now, I just want to check something. When I connect the signal down here, where is it now? Update enemy waypoints. I mean, update waypoints here. It was here somewhere. and connected signals. Or perhaps I do it in the other one on enemy ship behavior. Here we go. Health, connect, the signal, and all the callables. So that means, and the parameters, not the callables. So that means if I go to the behavior manager, that means the signal itself has no parameters, which is fine. So let's do this. Pattern assigned and pattern cancelled. But you know what? Let's just copy this name. And we'll make sure that it's pasted there, like that, properly. And now we'll say another signal, pattern cancelled. And confirm the spelling is the same. Okay, let me just save that. Pattern assigned is not found. Enemy ship controller dot pattern assigned dot connect on pattern assigned. Oh, come on. Let's just attach it to this node in the meantime. On pattern cancelled. Takes in an enemy ship ID. So let's just do that here. I see. So this is for assigned. And then this is for cancelled. Save that. Save this. Why is it complaining? So what's happening here is it was trying to use a parameter from the function that was calling the function, right? So here you see it's saying execute pattern. It's calling the execute pattern function, right? And then inside the execute pattern function, it's emitting a signal with enemy ship ID, as if this enemy ship ID was a parameter here, but it isn't, right? And so it's saying, oh, okay, well, you know that this is not defined in the current scope, right? And so what I did instead is I said, okay, well, we know that enemy ship ID is a global scope variable for the script. And we'll just call the enemy ship's ID, because type enemy ship should have its own ID, right? And that's what we did. So instead of that, then we did enemy ship .id, and that fixed the problem. Instead of using a parameter variable and worrying about scope and relevance. So that fixed those two errors, but these two errors are still a problem here, right? Now, I'm not sure how else I can fix this, because enemy ship controller now has these two signals. And there are warnings about them. Let's see what it says. It's declared but never explicitly used in the class. And I'm trying to find out why. This is exactly, by the way, this is exactly why I didn't want to jump straight into the code, to avoid problems like this. I really don't like debugging. And now we've got this. So, okay, let's do this. Let's copy the code, all of it, paste it into DeepSeek, and say we've got these problems, right? So here is the code for the NPC behavior manager. We'll paste that there. Okay. And here is the code for the enemy ship controller.gd. I'm getting the following error messages. For the NPC behavior manager script, and I'm getting the following warnings from the enemy ship controller.gd. Script. declaring the signals in the enemy ship controller class didn't remove the error the way I thought it would. So please help me figure out why the error persists. Okay, so it's saying that I need to instantiate enemy ship controller.gd, but the thing is that this is a singleton. Use an autoload. If enemy ship controller is an autoload, then do this. Enemy ship controller is an autoload / singleton. I thought singletons didn't need to be instantiated. I see. So it's saying I still have to reference them correctly, even though I'm not instantiating them, right? So I'm using the class name enemy ship controller instead of the autoload name, right? So in Godot, when you create an autoload, you give it a name like enemy ship controller. Oh, of course, of course. Oh, how foolish of me. Yes, I remember this now. Yes, okay, so that's my mistake. And if I go to the project settings and check the globals, we'll see enemy ship controller like this. So that's the singleton. Okay. Enemy underscore ship underscore controller. So it should be underscore ship controller like this. And now we are talking. See, now we have all our functions and everything working nicely. Amazing, amazing, truly amazing. Okay. Clean that up. And what are these trying to say? The parameter behavior type is never used, and the parameter delta is also never used. We can ignore those since we might fix them. Well, we will fix them. Well, at least one of them will fix. Parameter behavior type will fix that in time. And delta, we might never use because process is not being used currently. And so we might end up removing the process function completely, right? You know what? Let's just get rid of it now. Why not, right? Because we're not using the process function. There's no need to keep it around. And if we need it, we can just add it in because we know that there is such a function as the process function. We know what it's for. And yeah, so then we'll just deal with it back then. Behavior type is a string. Why aren't we using behavior type? See, we're using status. But we're not using behavior type. You know what? For now, like I said, we'll ignore that. We'll deal with it as we go. Okay? So this is a class name in PC Behavior Manager. I just want to check something. It's a type enemy ship, right? So let's try putting type at the front here. Because remember, like I said, singletons and singletons and signals and whatever, right? They all end up looking the same, right? With either with underscores or no underscores, or lowercase with underscores, or uppercase with dashes, or whatever. There's only so many ways you can say the same thing without, without clashes. And so for classes, we can add this nomenclature, this prefix, right? Where we add the type underscore, just to emphasize that this is a class type. It's a class name, right? A class name, and then when you instantiate it, then the object of that class is of type, whatever the class name is. So it's type NPC Behavior Manager, and type enemy ship, and type waypoint, and type this and type that. So let's keep it like that. Because remember, like I mentioned before, there's groups. Okay, so we've got groups, and we've got signals, and we've got classes, and we've got all kinds of things. Singletons and signals and group names and all these things. And there's only so many variants you could apply, right? So we'll just keep it like this, where we have the type prefix. So that's done. And now we can go to making the seek function. So let's go into our file system, and then under behaviors, steering behaviors, so let's create a new folder and call it control behaviors, right? So control behavior scripts, right? So now what we want to do is we want to put all the control behaviors in control behavior scripts. So that means things like the behavior of the barrel, and actually no, let's make another folder, and we'll call this one component behavior, right? Component underscore behavior scripts, right? So now the component behaviors like barrel behavior and bolt behavior and gun behavior for the player and the NPCs, and health behaviors and target behaviors and waypoint behaviors, these are all components, right? And so we want to store them all in a folder dedicated to the behavior of components, like that. So now we've got a folder for components, we've got a folder for steering, and now we've got a folder for control as well, right? And this is where we'll add a new script called shoot. Just simple, plain and simple shoot.gd. Okay, and now if I go into the gun behavior, hang on. Let's just open up shoot.gd. And now if I go to behavior gun, you'll see that there's shot cooldown, shot trigger, shoot, and so on, right? Now, what I want to do is put all of the shoot logic into a shoot script instead, and add that into the steering manager. Although this isn't, surely it's not the steering manager, it was a behavior manager. Didn't I name it the behavior manager? I'm sure I named it the behavior manager. I'll just use page up to go faster. Yes, behavior manager. So that's my mistake. I named this thing incorrectly. NPC steering manager. This should be NPC behavior manager. So let me go to my scenes, components. Here, this rename to be behavior manager. Because remember, the behavior manager manages all behaviors, not just steering behaviors, right? And then here we rename this as well to be the behavior manager. All right, that's good. So now if I go here, you see that there's all of this. So now I could add under components, if I go into the components, steering behaviors, and then a new folder called component behaviors. See, I don't like everything being so random like this. We'll say entity components. So create new folder. Not entity components. Player components. And enemy NPC components. So NPC underscore components and general components. Okay. Wait, what? All right. So now enemy ship controller and gun NPC and NPC behavior manager can all go into NPC components. Then the health, the orbit camera, the plasma bolt, target, waypoint, and mining target, they can all go into general components. And then the gun for the player goes in the player components, right? So now it's nice and tidy. And then I can go into like rename this to be behavior components. Okay, and then in behavior components, we can add steering, behaviors. And we can add general behaviors. Then we put this into steering behaviors. And we can make a general behavior for shooting. So a new scene called shoot.scene. And that's a general scene, call it shoot.scene. All right. And in shoot.scene, we can add the control behavior for shoot. Okay. So now we've got the control behavior for shoot. We can add the logic into shoot, and then we can control shooting in a more general way rather than very specifically. But for now, let's not worry about that. Okay. We'll worry about the seeking first. So if I go here, there's a seek behavior.gd and there's a seek scene. So we'll save this. And on here, we can add the seek behavior. Where's this thing called seek behavior? Yeah, seek.gd goes onto seek. And now I can open up seek.gd and we can put the code in, right? So that will be the next step. I'll save it here. And then in my DeepSeek, we can ask it to extract the code from the enemy ship behavior and put it into this behavior instead, right? So let's give it all the necessary script files. Where's this thing now? Enemy ship behavior.gd and enemy ship controller.gd and the npc behavior manager.gd, and then make it right seek.gd. Okay, so we'll do that first. We'll go enemy ship behavior, copy this and paste it here. First, we'll give it some instruction, right? I want to implement the seek.gd behavior next. Here is the enemy ship behavior.gd file. And here is the enemy ship controller.gd file. And then we'll have to copy the code from that. Enemy ship controller, copy all, and then paste it in here. All right. And then over here, we'll say, and finally, here is the npc behavior manager.gd file. And we copy that and paste it here. Please use the scripts provided to extract the seek functionality from the enemy behavior .gd file and place it into the dedicated seek.gd file instead. you're right. We should have this prefix behavior underscore. So let's do that quickly. So this should be called behavior seek. Behavior underscore seek, and then the seek file should also be renamed to be behavior underscore seek.gd. Okay, and then that's fine. We just confirm that all the GD script files are uppercase separated by underscore, so it should be behavior underscore seek uppercased. So this should be behavior underscore uppercase seek, like this. Okay, and then if we go back to our code, let's just do a quick this is hardly quick. This is a massive file, but okay. And then it should say update the enemy ship behavior.gd to have no seek functionality, right? And then the key changes. We remove the seek function, the accelerate function, the waypoint export variable, and the process function. And then we removed enemy reached waypoint signal, and the behavior seek now handles all seek functionality and communicates completion via signals. The enemy ship now relies on the behavior manager and the individual behavior nodes for its movement logic, which is how it should be. That's what we want, right? So I think we can take the rest of this session and just make sure the seek script works properly before we implement it, right? We don't want to have to put it in, find out it doesn't work, and then slog through all kinds of debugging steps to make everything work. Let's make sure it works first and correct DeepSeek if we have to, and then we paste the code in. And then if we have to call any corrections, it'll be a lot less and a lot easier. Okay, so let's go through this. Extends node, that's fine. Class name, behavior seek, perfect. Although it should be type behavior seek. But that's okay. We don't have to nitpick that part. We can change that ourselves. And then it's got a signal for behavior completed, where it lets people know who completed it, what was completed, the status, and any data as a dictionary. That's fine. And then we've got enemy ship, which is of type enemy ship. We are creating an instance of the enemy ship. And I think in the ready function we do. We don't. Well, that's a little concerning. Anyway, we can fix this by saying some corrections. Okay, so here are some corrections I have with your behavior underscore seek dot gd file. Firstly, please use the type underscore prefix for all class names. This disambiguates the class name from all the other similar names like group names, singletons, etc. Secondly, I don't see where the enemy ship variable is initialized. Surely this needs to be connected to the actual enemy ship, or to the relevant enemy ship. Okay, so those are my two concerns so far. We'll add more as we go. All right, then it's got a target position vector 3. This is the vector position of your target for seeking, right? So you're seeking this target at this location. Go to these coordinates, basically. And then you've got behavior parameters as a dictionary. Is this behavior currently active? So there's the is active boolean, which is set to false automatically by default, rather. And then we've got the activate function, right? So when we call activate, then the enemy ship ID is taken in as an integer. The behavior parameters is the dictionary. Oh, here we go. Never mind. I see you use it in the activate function. You initialize it. Initialize in the activate function. So I'm going to leave it in. I'm not going to take it out. I'm going to let DeepSeek know that I found this as a problem when I was reading through the code, but I see later when I read through the code further that my concern has already been addressed, which is fine. It's already doing that. See, enemy ship.get is getParent as type enemy ship, which is perfect because the parent of the seek node, the behavior seek node, is the NPC behavior manager, and the parent of that will be the enemy ship. Okay, so that's fine. Then we've got if not enemy ship. So if we can't get the parent, right? For example, if we instead of connecting this to an enemy ship node, we connect it to something other than an enemy ship, right? So if getParent.getParent is not a type enemy ship, if it's a waypoint, or if it's like an actual scene, an open scene, the whole scene, right? It could be something or anything, we don't know. Or for whatever reason, if it's a null, if there's no parent.getParent, if it comes back as null, in any of these cases, you could say push the error, behavior seek could not find enemy ship, and then behavior complete.emit and emit the signal, right? Who completed the behavior? What was completed? What is the status? And any data connected to it, right? So this enemy ship completed the behavior. Seek is the behavior that was completed. It was completed through failure, so it failed. And here's the reason. The reason is that there was no enemy ship. Okay, so you see here, this is a dictionary, right? The key maps to a value. The key was the reason. The value was that there is no enemy ship. And remember, in Krita, I showed you that there are key and value pairs in a dictionary, right? So the key and the value, right? So in this case, the key was the name or the type of behavior, right? So behavior underscore seek, and the value would be in our naming convention, that would have been behavior seek.scene. So then and the same thing here, right? Behavior shoot, the value would be behavior shoot.scene. So the key connects directly to a scene in this case, whereas over here it's mapping a string to another string, right? The reason to the actual reason. Okay, and then after that we return, and remember, return just takes us out of the function. So if we couldn't get the enemy ship, we close the activate function immediately. We don't carry on with everything else. We just ignore all of that. We just come straight out of the function after having emitted the signal saying, hey, hang on, there's a problem here. There's no point carrying on. If we carry on, we're just going to cause further problems. Okay, and there's the parameter. The parameters variable takes in those behavior parameters, right? And we then set is active to true. And remember now, if we couldn't get the enemy ship, there's no point setting is active to true because the behavior is already completed because it failed. Okay, so we'll continue now and say if parameters, which is a dictionary, dot has a target position, okay, then target position is parameters with target position. Remember now, with a dictionary, you index a dictionary differently to the way you index an array. With an array, you index a position in the array numerically, whereas with a dictionary, you index a position in the dictionary by the key. Okay, so I would say here, if I want to get seek.scene from the dictionary, I would call dictionary at index behavior seek, dictionary at index key, and that will give me the value seek. Okay, same thing here. We are doing if it has a target position, then get the value from target position's key and assign it to the target position variable. Okay, and we've defined target position up here as a vector 3. So the next step, if it has target position, then do this. If it doesn't, then check if the parameters has rather a target node path, and the variable target node is assigned enemy ship.get node parameters at key target node path instead, right? And then assign that to target node. And then if target node is not null, then set the target position based on the target node's global position, right? And if we can't do this, right, if it's a null, if there is no target node, if this is a null value, then we'll say else behavior completed, emit enemy ship ID, seek, failed, reason, invalid target path. Okay, so we emit the signal, who did it, why, who completed the behavior, what behavior did they complete, why did they complete it, or rather, yeah, what was the status of completion, and then any data, yes, there's a reason. What is that reason? It's an invalid target path. Okay, and then we call return because again, there's no point continuing after this, and so we return out of everything. So return out of this, and out of this. Okay, and if neither of these work out, right, from this point, remember, here we've already passed this step. This step has already become true because parameters does have a target node path if we reach this line, right? But if we can't reach this line, it means that, well, if we are evaluating this line, it means that this line has failed, okay? And if we are evaluating this line, it means both of these lines have failed, right? So if and else if have failed. So now we are going into the else statement. And in the else statement, we are emitting behavior complete.emit enemy ship ID seek failed reason no target specified. Okay. And then we return out of this. And if all has gone as planned, so either this has passed and we did this, or this has passed and we did this, and this has passed and we did this, right? Because this hasn't come through and we haven't returned, and this hasn't come through and we haven't returned, then we get right to the bottom and we can then print this message instead. Okay, print seek behavior activated for ship with enemy ship ID, and we say targeting and we put the target position down. Okay, so that's good. The activate function seems to make sense. Everything works as expected. Then we've got this deactivate function as well. Okay, so we set is active to false and we print a message which is nice and readable for us, the developer, and you as the audience. We print a message saying that the seek behavior is now deactivated. Okay, and then we've got a process function here, function process delta, if not is active or not an enemy ship. So if it's not active or if it's not an enemy ship, then return. No point carrying on, just close the process function. Okay, and if this is not true, so if it passes this check, that means that something is wrong. If it fails this check, that means everything's fine. Okay, I know it's counterintuitive to say it fails, so then carry on. But okay, so if it gets past this, right, then we calculate the distance to the target. Okay, so we set up a variable called distance to target, and we say the enemy ship's global position origin dot distance to a target position. Okay, so this is actually nice and neat. It's all in one line. We don't have to do unnecessary calculations by hand. By hand, I mean manually type out the equation ourselves. It's already built into the engine, which is so nice. So we're basically saying the enemy ship's global position, right? The global transform dot origin, because every transform has an origin. And let me just show you what I mean by doing this. If I go to the pirate enemy in the 3D scene and I show you the enemy ship's route, you can see the gizmo, right? The gizmo are all of these things. All of these parts are the elements of a gizmo. And you'll see here that whether I'm rotating or translating, right? So translate is this, the arrows to move on either of the axes or along a plane, right? So if I do this, you'll see that it's moving along a plane, right? I can do planar movements, but I can't move it along the z-axis, right? Whereas if I do this, I can move planar movements like this, but I can't move it along the x-axis. And let me just show you what I mean even more clearly, like this. So I grab this, and you'll see now I'm moving it, but as much as I try, I can't move along the x-axis. Okay, and then for scaling, I can do something similar, but let me just show you gizmos. Why doesn't the transform allow me to scale things? Move, rotate, scale. Ah, there we go. So in scale mode, you see now instead of transform, we've got scale, those blocks, right? And you see now if I drag it, I'm scaling rather than translating. Okay. Now, I don't want to tamper with this scene too much, but I hope I've explained very clearly what I mean, right? Now, if I go here, you can see that's the global transform, and every transform has an origin. Okay, so get the origin of our transform. So once again, the origin of the transform is that point there in the very middle. Okay, here at the very center of the transform, get that origin point and then calculate the distance, right? So calculate the distance to the target position. And if you remember, target position up here is a vector 3. It's a vector of 3 values, x, y, z. Okay? And calculate the distance to that. So how far are we away from that point? Okay, then the next step is, if the distance to that target position happens to be less than a single unit, it means that we've reached that waypoint. Okay, and we just print out that the seek behavior has been completed, the target has been reached. We emit the signal, right? Behavior completed dot emit enemy ship.id saying, hey, I've completed this behavior. The behavior that I completed was seek. The status is completed, and the data that is attached is the target position as the key, and the value is the actual target position, and the final distance as the key, and the distance to target is the value, right? And then we set is active to false and return. Okay? And at the end of all of this, we then call seek target. Because again, remember, this is a sentinel body, right? A sentinel body. And what that means is it's a specific term in computer science and programming. A sentinel, it's either called a sentinel statement or a sentinel function or a sentinel expression or sentinel something, right? And in this case, this is a sentinel if statement with a sentinel body, right? So there's a sentinel if statement, and this one here too is another sentinel if statement. So if it passes this sentinel, right? And sentinel just means someone who stands guard at the door, right? So we could call it a gatekeeper if you want to, right? So this is a gatekeeper. It checks if either of these are true, then there's no point carrying on, right? I mean, if either of these are false. If either of these are false, then we can't carry on, right? If it's not active, or if it's a null enemy ship, or both, then there's no point carrying on, and so return. And if both are true, right, it's active and there is an enemy ship, right, a parent enemy ship, then we can do this, and then we check if the distance is less than 1, it means that we've already reached our target, there's no point carrying on, so close the function. But if it's not, right, so we could even have put this in an else body, right, but we didn't, because there's no point. It's the same thing whether we put it in an else body or not, because this is a sentinel if statement, a gatekeeper. And so now we check, okay, well, if it isn't less than 1, then we still need to call seek. And so then here we go. We call seek, and now in the seek body, I realize that we already are on almost on the hour, right? So I'm going to try and get through this as fast as I can. But before I do, I'm just going to quickly make a shout out to Cubes. Thank you so much for your support. He's a junior DevVenturer in the membership tiers or levels in my coffee.com/mtkdev page. And if you want to join him, you're more than welcome to. And I thank you in advance for your support as well, right? And you don't have to be a member. You can do a one-time donation too. The link is over here if you want to get it. Otherwise, you can check the description as well. Also, please don't forget to join the Discord server to join our community. You'll be updated on all of my content, whether it's on YouTube or otherwise. You'll see it all there, and you can also engage with community members on the Discord server. So I hope to see you there. Okay, now back to the code, right? So the seek function is as follows. We've got a direction to target, which is our target position. And as you remember, target position up here was a vector 3, okay? So we're taking the target position and subtracting the enemy ship's global transform dot origin. And we are normalizing that, okay? So for those of you who don't know what normalize is, I think I might have covered this before, but I'm going to quickly mention it. All it does is it takes the values and it squeezes all of the scale out of it. right? So it just compresses it down to a value between 0 and 1. It makes it basically a percentage. It turns, okay, so mathematically speaking, what it does is it turns it into a unit vector, okay? And it takes all the magnitude out of the vector and only shows you direction. Okay, that's what normalize does. So this is just it's extracting the direction from the vector and ignoring the scale. And then that's why it's called direction to target. Okay, and so here we've got another variable for the target rotation, okay, which is the enemy ship's global transform dot looking at. And then we say we are looking at the target position, and the up vector is vector3 dot up. Okay, and this whole thing dot basis. Now basis is a very specific thing. You don't have time to go into it right now, and I will have to look up an explanation for it in any case, because I don't know that explanation off the top of my head, unfortunately. So you'll just have to bear with me on this one, and we'll just continue. Okay, same thing here. Current rotation also uses a basis, but this time it's the enemy ship's global transform dot basis. And then we apply the rotation with inertia. So the enemy ship dot global transform dot basis is a new basis that takes in the current rotation dot slurp, and slurp stands for smooth linear interpolation. Okay, so current rotation dot slurp, target rotation, enemy ship dot inertia, and then we calculate the velocity, the variable for the current velocity, and then we assign it the value of the negative enemy ship global transform basis dot z times enemy ship dot current speed. And if we look further up, enemy ship dot current speed, oh yeah, that's a member variable of the enemy ship class. Accelerate if needed, if the enemy ship dot global transform dot origin distance to target position is greater than 1, right? Then call accelerate, which is enemy ship dot top speed. Accelerate to the top speed, right? And apply the movement enemy ship dot set velocity, current velocity, and enemy ship dot move and slide. Okay, and then accelerate, only accelerate if needed. Okay, so accelerate to a target speed, which is a float. If the enemy ship's current speed is less than that target speed, which we pass in as a parameter, then we say enemy ship dot current speed is equal to lerp, not slurp, lerp. Okay, and lerp is linear interpolation, and slurp is just a smooth lerp, which is a linear interpolation. Okay, so enemy ship dot current speed is a linear interpolate from enemy ship dot current speed towards target speed using enemy ship dot acceleration as the increment. Okay, so it's just go from this point to that point in these steps. And then if it doesn't, right, if it's not less than target speed, so then else, then we say enemy ship current speed is assigned the value of target speed. Okay, and then update the behavior.gd. That just changes where we remove the seek functionality from it, right? Here's the key changes. All is well, and I can then post this and get the corrected code, and it should be the same. It's literally just going to have type underscore. Okay, you're absolutely right. Here are the corrections. Behavior, instead of behavior seek, it's type behavior seek, and it continues to write. But in the meantime, while it's writing, I'll just close off the live stream because there's no point going through the code again. Okay, so thank you so much for your time and for your attention.